all the work is here, but let me talk through it. Okay, so if I want to find y prime, I'm taking the derivative with respect to x on both sides. So when I start taking the derivative of this, I have e to the stuff. And when I try taking the derivative of stuff, I say I have quotient rule. So that's low d high minus, right, high d low, square the bottom, and off you go. So that's what you see right there. Okay, so then I move to the right-hand side. That gives me x squared. This is just like saying, I'm going to make sure you see this, a minus 1/4 times an x squared. So I bring the 2 down in the front, because 2 over 4, y to the 1 power times y prime. Okay, so this is harder algebra. It's not harder derivatives, but I see that in order to get to that y prime term, I have to separate around that subtraction. So I make 2 separate fractions. So this is going to be a tool that we will use often. Make 2 separate fractions. Let me erase my little dots here. So I've got 2 separate fractions, and then I carry these guys along, and then I take another algebra step and just distribute. So I get to this. So now I can identify my y prime terms, because that's always the deal, right? That's a y prime term. That's a y prime term. So I pulled them over to the right-hand side, factor it, both bits, added this one, subtracted this one, factored the y prime out of this, and then divided. That's pretty challenging, right? So it's algebra. It's a lot more derivative challenge. All right, so I'm going to take the derivative with respect to x on both sides. So take the derivative of the cosine first. That gives me negative sine. Carry the angle along. So then when I'm taking the derivative of the angle, the derivative of x is 1. And the derivative of y is y prime. So you have to put that in parentheses. Big, big, big deal. Okay, so now I take the derivative of e to the stuff. It's e to the stuff. Oh no, and when I want to take the derivative of x cubed y, I have to use product rule. First d second, derivative of y is y prime, plus second d first. Okay, so I need to distribute on both sides. So let me just kind of show color. So I take this times the 1 and this times the y prime. So this times the 1 and this times the y prime. Okay, let's jump over to the other side. I'm going to take e times this, so e to the x cubed y times that first term, and then e to the x cubed y times the second term. Whoa. Okay, now I can finally work on identifying where the y prime terms are. That's a y prime term, and that's a y prime term. So I pulled them over to the left-hand side, so subtracted, kept that one there, moved this one over, factored out the y prime, and then divided, all happy and good. So lots of algebra to distribute to isolate those y prime terms. You did that a lot before. Okay, now we're moving into lots of different letters. So if I have x's and y's that are functions of time, we do not use the notation of y prime. I will take many points off if you use y prime when we have dy over dt or dx over dt. So this says find let me make it bigger. Find dy over dt if dx over dt is 10 when x is 8, and this is the equation. So we're going to be digging more into this, but this is what we're trying to find. This is one of the equations. I'm sorry, one of the givens. This is another given, and this is another given, right? So the equation, the when information, and a derivative. So first we're going to take the derivative of this with respect to t on both sides. So let me erase so I can point out. Do you notice, whoops, you notice it's d over dt. It's not over d over dx. It's d over dt. So if I take the derivative with respect to t, let me just write it over here, derivative with respect to t of xy, the derivative with respect to t of 4. So the right-hand side turns into 0. This left-hand side, I can see there's a product rule. So I need to do first d second. D second has to be written as dy over dt plus y d first. The d first has to be written as dx over dt. Okay, phew, got the equation. So now I want to use x equal 8 into the original equation. So x equal 8 in here gives me y equal 1/2. So I can put the x equal 8 in, a little color here, x equal 8 in, and I can put in the y equal the 1/2, y equal the 1/2, and I think they give me, don't they? Don't they tell me that dx over dt is 10? So I can replace 10 here. Look at that. Now I can solve for the dy over dt. Whoa. Getting a little harder, right? All right, so let's try this one. So this is the question. Find dx over dt if dy over dt is this when x is 25, and that's the function. So since I see dt's down here, I have to take the derivative with respect to t of both sides. Derivative with respect to t. So I still do the power rule, so there's just a y there. So this is like a dy over dt, and you have to write that, not y prime. Y prime is reserved for dy over dx, and this is dy over dt. Okay, so on the right-hand side here, I'm going to bring down the 1/2, x to the negative 1/2, and then times the derivative of the inside, which is dx over dt. And that's what this is. So then all I did was, let me erase here so you can see what I did. I plugged in the x is 25. So I put the negative 1/2 power in the denominator. That means 1 over the square root. I put in the dy over dt is 2. So I put 2 in there. And so I've got this equation. So if I multiply by 2, I get 4. And then multiply by 5, because that's the root 25. And I get dy over d is 20. All right, let's try and, let's stop here.